Hey everyone, how are we doing? It is Tuesday, second day of classes. If you're here, say hey in the chat. Let's wake up Mubot. Mubot is not awake. I feel like, oh, I changed the screen size on this. That's why that's a little bit small. There we go. That's how things should look. Reorienting my screen, getting things the way they should be. We'll see if anyone's in the chat. I'm on top chat. Hey, long hair, Brian, Marjorie. I know the hair's getting longer. Great to see you here, Marjorie. So yeah, the hair's getting a good bit longer again. Not quite. Not it's intermediate hair length. Let's throw out some Mubot points. Great to see you here, Marjorie. Do you have any questions? Are you taking 320? Are you taking any of the classes this semester? But no, it's so good to have you here. I tell my students that former students swing by all the time. We throw out some points. I don't think Mubot's awake though. I think Mubot he's sleeping on the job. As per usual, doing his Mubot. Says bot's been connected. Mubot. Is he going to talk in that he misspelled? I am awake. No, just creeping in for my paleopathology. That sounds super cool. Well, thank you so much. Mubot's telling us all he's awake. Paleopathology. What kind of class is that? Paleopathology. I've never even heard of such a class. Oh, there we go. Mubot's adding points now. For some reason, the first few times I do points, sometimes he doesn't do it. I have no idea. Mubot is a weird bot doing his thing just randomly. But Marjorie, so good to see you here. I hope your semester's going well. Yeah, I just like, I read usually the UTK Reddit. It's sad. It's like I don't get to like be on campus right now. So I'm not like seeing everybody. And so I go to the Reddit and it's like my venture on campus to see what Reddit's talking about, to see if anything's happening on campus. So I only know, does UT still carry out donors at, oh, you carry out. Wait, through Grubhub? You can do carry out at UT through Grubhub? You can get what? Wow. So apparently you can get carry out UT dining from Grubhub. That's pretty crazy. Didn't know that. See, this is how I learn everything. What is this? Let me see right here. I take for example. Oh, let's see right here. Oh, pretty interesting. This is an interesting post. This is so interesting. Ooh, there's issues. Whoa, this is an interesting post by this user right here about third-party service. We're using Grubhub. So now someone even says, and now for Treyas, and we're using Grubhub. Okay, wait. So what was this? We started using Get Mobile. So that's interesting. Well, I'll have to read this more directly. Yeah. Why is American Fresh Food Company acting like that? Ooh. I'm trying to think of Zoom, Teams, and this is such a good question by this person. That is, and so they're right on some stuff. Haslam College of Business is very direct in how we should roll things out. I think maybe they're seeing some college to college differences. Like maybe I'll reply to that Reddit person. But I know Haslam College of Business gives like more of a direction. Good thing they didn't say, why is one teacher teaching on YouTube? Why does one teacher teach on YouTube? Why does he do that? I don't know. I'm lucky. That's why. I don't even know. People might still be here. I'm just talking to myself. Really good questions. Really good questions, though. Really good questions. I think a lot of direction. Like there's the university direction, there's the college direction, there's the then there's like the departmental direction, and then you have instructors from there. And so the cohesiveness of the plan can kind of change or get disrupted because it's very hard to have one, and it's better. It's better when there's one cohesive direction. But then you don't want to, as like leaders, because I've led teams, tell everyone they have to do exactly the thing you're doing. So you run into this issue of like freedom versus cohesion, and it's going to be better experience-wise when everything is more cohesive and everything follows the same exact structure. But then you run into the problem where, you know, someone might have great ideas. That's going to stifle creativity, and maybe there are benefits to certain things. So then it's a balance. It's really tough. It's such a great question that they're asking right there. It's like I think they're seeing, especially when you go between like college to college, that's probably where you're going to see the most differences. Um, but yeah, I mean, you got this person in Haslam teaching on YouTube, so he's not following the structure right there. We'll see if anyone has any questions. I'm just talking to myself, reading chats. People saying I am 201. That is our big conversation right now on the Discord. Lots of people have joined. I'm seeing we need lots of people don't have roles right now. I wonder if we could tag everybody. No roles. No roles, I think. No roles. I'm going to say something to the admin. Admin. Oh, no, that's the wrong person. Is there any way to mass tag people with no roles and tell them to go to request house role and select the role? Tons of people joined today and like 10% chose a role. Trying to make everyone have the best experience on the Discord. Now you're just hearing Brian's thoughts and welcomes to Brian's thoughts. There's not much going on in his thoughts. Right now, just making sure things are organized, talking to the admin on the Discord, trying to get everything, making sure. Oh, got some message right here. Awesome. You have the Stats 1 role. Good stuff. If you join in right now, feel free to ask questions. Maybe I should put that on the screen behind me. Let me say, if you join, I'm about to have my 10 billion Word documents open. All the Word documents. Let me put this on the screen here behind me. Okay. So feel free to ask questions. Brian, wonder if I could do a scroll. Let me put that as a scroll at the bottom of the screen. That'll be interesting. Never done that. Or I haven't done that recently. Okay, so let's try that. Let's try something new right here. Let me send this person a quick message. The account. And I can then give you the class role. Are you trying to add 201, 320, another class? Okay, there we go. All right, let's see if people join it. I'm gonna try to put a scroll at the bottom of the screen. All right, to do a scroll, you have to go here. I think text. Okay, let's say taking questions. Okay. Cool. Text transform. No, we don't want that. No, maybe. If you join in, feel free to say, hey, Brian's figuring out. Brian is currently. You see, there we go. It's just going to do this. And then we got to make it smaller. Brian is currently taking questions. Just put it right down here. It's going to be way too big still. Brian is currently taking questions. Ask away. There we go. Boom. Brian is currently taking questions. Ask away. Right here at the top. We don't need to scroll it. We'll just put it right there. We got that taking questions text right there. Brian's currently taking questions. Ask away. So I'm going to look around and see what people are saying online on everything and make sure we're all caught up. Cool. They're sending an email. Let me go over here to my emails. It'll pick up here. Okay, wait, here we go. Great question. Let's see. Oh, one's joined in. And there we go. If you join in, ask questions. Someone might join in, say hey, or have questions. Awesome. I'm going to validate this person on the Discord. Okay, I'm going to go to the Discord. Awesome. And you. And let's see. Oh. Oh. Let me add the student. No one said anything yet online. Okay, so where? Oh, I don't see them. Let's see. I don't see them. I'll put on some chill music here while we're relaxing. Why does it keep doing that? Is it that button? No. I need to disable that. It keeps bringing up the little news thing. I have no idea why. So odd. Let's see. Okay, good. Got that done. Cool. Waiting for them to post and I can fix it. Fixing things. Fixing things on the Discord. Let me go to the admin channel. Trying to remember to fix this once it happens. That way I can fix their role. Let me go to Yay, Jack, good to see you here. Stat Hype. How was the first day of classes? Went well. Here, let me go over. I'm gonna no roll. Awesome. Jack, let me say hey over here on the chat. And Zach's here. Let me hop back over here. Social Lifestyle stop by. Zach, so great to see you. And Jack, so great to see you. First day of classes went well. It was busy. Mewbot's chatting it up there in the chat. Stat Hype. No, it's so good to see everybody here. I'm working on the Discord right now in the background since there's no big questions, but I'm watching the chat also on the main screen, which is why I'm looking this way probably. Usually I watch over here on the side screen so I can see what's saying. How'd your first day of class go, Jack? How'd your first day of class go, Zach? How's your semester going? Tell me about it. Tell me how life's going, how class is treating you. Feel free to share. It's I'm just glad to see so many former students. Mewbot's giving out those points as per usual. I like seeing former students swing by, say hey. And we're just fixing up the Discord as we talk. The neural channel should just be... Yes. Should just be... Hashtag... Oh. see. Got people joining. Okay. Okay. Here we go. Let's see. Me too. Let's hear it. Oh, I see more people. Marco says, hey, Brian, just curious, as I pursue internships for the summer, what softwares will we be learning as business analytics majors? Such a great question. Great. I have Tuesday, Thursday off, so I'm back from running errands. Nice, nice. I'm going to send back our PlayStation controller on Friday. That's going to be my errand day. So it helps to have a day. Marco, such a great question. Let's go talk about that, Marco, over here. I've got a ton of stuff open, so give me a second right here. I'm just going to make sure load up some R right here. So let me turn off the questions right here. Marco, such a good question. Let's talk about software in business analytics. And let's go over here to software in business analytics. Okay, let's go. Great question. Okay. Software is, yeah, it's so nice to have like a day to do something. Like I was trying to do that. Software in business analytics. Let's go check that out. I forgot I got this transition on still. So I might have to keep it on for later. I worked on a new transition right here. So lots of different software packages that people use, but probably one of the primary ones is going to be R in RStudio for us. We also have things, so we can take some notes right here. Let's go ahead and enhance font size a little bit. So we've got here R in RStudio, R/RStudio. So R is now, it was pretty smooth. You like that, Jack? Awesome. Yeah, I might keep it on. Who knows? I could go back to the Stat 201, but yeah. But it was fun. Pokemon change. I forget I have it on. R is the language, and I think R is even built off another language. Like people have gone into greater detail, and I've read the Wikipedia on it. But think of R as the language, and then RStudio is basically this thing right here. So when you think about like Windows is going to have code behind it, code behind Windows. Is Windows in C++? Maybe, or C# or C something. I don't know. And then Windows interface. So if you're using Windows or Mac OS, like RStudio is what we call a GUI, GUI, graphical user interface. So it lets you interface with the stuff right here like I'm doing. From first glance, it reminds me of C++. Yeah. And that's what we want people to think. Like if you've done a little bit of coding, you're like, this looks a little bit like coding right here. So Jack, I guess, Jack, you took 201, right? What do you know? What is Brian making right here? Because I'm not writing code, I'm writing these, which I can just write anything I want then. What do you think I'm making right here instead of writing code? Best Nemo file ever. Instead of writing code, Brian right now is creating these. And this is something we'll learn in 320 on the first few days. Like we'll talk about, oh, Brian's just adding this to his code. Like I could say like 2 + 2 and say, this is math. So right here, that thing after it, which doesn't show up, is a comment. Throw out some points. Jack might know that. If you've done some C++, you probably know about adding comments to your code. So that's just like a little telling someone what that is. This is math right here. So a lot of times people add comments so they can see what's going on and they can remember if they go back and look at their code. So R in RStudio, like R is the thing running the code. RStudio is the thing giving me all these like ease of use things. Someone could just use R. Like someone could run all the code behind Windows, but using Windows just makes it easier. There's other interfaces like Jupyter Notebooks, and there's other languages. Yep, comment here. There you go. A little ////. Looks like HTML right there, calling some backslashes to me. And so each coding language has its own way of doing certain things. So this is probably going to be, you know, like some of your main programming skills. Now, when we get down to other stuff right here, we probably have things like Tableau. I think I'm spelling Tableau correctly. Tableau is going to be for graphics. You don't have to use Tableau. You can use things like R and RStudio. What's really, really great, and I'll show you this. Let me hop over. What do I have all open? Go over here. I'm going to reply to the person on Discord here in a little bit. Let's go to Plotly examples in R. So, Jack, you just got done with 320. 201, excuse me. For anyone who just got done with 201, what's really cool is we have ways of making really amazing graphics inside of R and RStudio that are absolutely awesome. Looks like here we got some bar charts. So we made some bar charts in 201. I think this is all being done through R, not Python. I think. Now this is going to seem like a lot right here. I think this should run. That does look like R. Oh, it's mad about dplyr is not on. Libraries are basically how you get additional codes, and it's saying the pipe was not running. And so, what is going on? Oh, it's working fine. Okay. So this right here are box plots. Oh, yeah, it's way easier. People consider R to be way easier. I got some hex color coding. It looks like, I don't, they're only using, there we go. This right here, we'll do some Rocky Top, FF8200. That should be Rocky Top colors. It's the background. So we did the background right there. They're doing, the line colors. That's white. Where's the blue coming from? Where's that blue color coming from? We just changed. Oh, I think the color is not being assigned up here to the bars. We don't have to plot background color. Yeah, that makes sense. Plot background color is now Rocky Top great orange. I don't even know what Rocky Top colors are. And then they're doing grid lines of white and stuff. I think it's, well, let's go right here and try, see if my remembers. F8, F9, BB. No, that's not it. Well, let's see what we get. So now we're going to change the grid line colors. And we get, oh, that's amazing. So if you see right here, we're just making some changes to it and trying it. And this is actually what I first started doing when I started creating graphics or started messing around with code, is just seeing what it did. And it's kind of neat what you can get. And these are interactive graphics that actually change to the page. So what you could actually do with this is you can actually put this on a web page right here, Jack. So if you put this on someone's web page or their mobile app, this graphic you're creating right here will change to the size of the screen. It's also interactable, where you could change like the bar itself. You can zoom back to where it was. And this is through a package called Plotly. So where we create graphics in 201 that look kind of nice, we talk about sometimes in our advanced classes, like how can we make really great looking graphics? Like how could you create a graphic that you could put on the web that someone could like trace over? And this is all once again being done via Plotly, which is something we can use. And we'll just take a tiny quick glance at that. But I would highly suggest looking into things. I just copy pasted their code. Are they not going to show the really cool ones? Here's some scatter plots. We did these in 201. So this is just a scatter plot right here. Here's scatter plots with nicer dots. Here's a bunch of like time series plots, it looks like, if the X is time axis. But you can plot multiple series. You can break things apart into groups. So all of this code right here is code we can just take, as long as this is the iris data set, we'll have iris data. Oh, I always forget they got those buttons there. So we can go over here and run the same sort of data. The iris data set is something that we have by default. It's already loaded in here, and now we'll get the same sort of plot. And what's really cool about these is you can take and remove certain things from it. So all of this stuff that we teach on how to make these graphics, make these sort of ideas, you can even go right here and zoom in. And as you can tell, this is going to be better, and we could add plot titles and all that great stuff to this. But we go over how to do this kind of stuff. And if you look, I'm just copy pasting code right now. I'm just going to a website using the code they have. And all the code basically is here's my X variable, here's my Y variable, here's the color variable I'm using. And then the colors they're specifying are from set 1. So they're using set 1 colors. So we could actually choose our own colors and specify a vector of colors. So I don't want to go into too much detail. I would also say we should make this code look prettier. Better looking code is going to look like this right here, where we put each argument. These are called arguments on different lines. So kind of neat stuff right here. Now you can see load the dataset iris, take the X variable supple length down here on the X axis, take the Y variable this, choose the color to be species. And you know what's really interesting? Watch this. We can go right here and comment out that line of code and not do that. Oh, I thought it was, there we go. We can comment that line of code. So we should see a plot now that doesn't have the colors assigned. So we commented out the whole color idea right here. Here's with the color, and here's without the color. So now we just have no color assignment of groups because we removed this because it's now a comment. So it actually reads through and then it skips this because it just says, well, this is just a comment here. So we commented out that one line, and that's kind of the neatness of how quickly we can change between these ideas of here's the groups in the plot and here's just everything as one group together. So really neat. And we could probably go here to color set 1. data, and this is a Plotly, just choosing straight from Plotly. It's so neat how these packages work. I'm trying to think how to change the color. Can we go color? Is it an argument? Color? Yeah. Of course, you know what we're going to do. Well, let's do this. Let's go teal. Is that going to like it? Oh, looks like it liked it. It's not teal. Let's say green. Nope, it's mad. That's not the right thing. It's saying, nope, that's not what I want to do this. It's giving me some sort of error message down here, scatter trace, blah, 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 and it wasn't giving that error before. So we could investigate. Oh, it's still giving the same error. Yeah, exactly. That's the thing. It's like, if you have a different data set, it's like, if you have data, I mean, this is what we teach in 201. It's like, here's the data set. And if you want to look at the data set, check this out. This iris data set, here, I'll store it so we can actually see it in the brain of our up here. What does this look like to you? Like, just tell me another thing that this looks like to you. It just looks like a what? Have you ever seen something that looks like this with rows and columns and like, and we got here this variable, like this variable, this variable, this variable, this variable. Here's the color thing. You ever see something that looks like this? Like any sort of program that looks like this? Like you open up something spreadsheet and you're like, oh, I've seen this spreadsheet thing before. So when you look at it, you're like, oh, there's the data. That's what it's pulling from to make the graphic that we see behind me right here. It just looks like Excel to me. It's like, oh, there's an Excel spreadsheet. You can even take exactly, and what's really great is if you wanted to do something in Excel, you could go write.csv and take your iris data and store it as, so the first argument is, what are you storing? And then what are you naming it? So iris.csv. And so I'm going to put up my block screen right here, but I just wrote the file to my computer as a CSV file. So I said, write this as a CSV file, and I'll make sure it doesn't pull up, like, do a ton of random things in Excel. Close out those documents. So literally here, and I'll show you something even better. I just took and wrote this as a CSV file. So I said, take the iris data frame, which is the first argument, the first thing. And then I said, my second argument is store it as a CSV. So we could pull in additional commands like with readxl, and readxl lets you use Excel files in here. This is what a library does. It lets you have access to additional things that people create. Like they go and take a book from the library and it gives you additional tools and techniques. So we could now go write.xl and take a look. It says write.xl. I didn't do it right. Oh, no. Oh, we have to go library write.xl. So I don't have the write Excel functions yet. And now take a look. Write Excel. Where's my write Excel function? There it is. Write XLSX. Okay, that might work. Let's give it a shot. So we're going to take the iris data frame, and then we're going to go iris.x. Now, these are just different file formats, like a CSV stands for comma separated values, where XLSX is the 2007 and beyond Excel format. XLS was the previous, before 2007, I think, Excel format. But the latest file format for Excel documents, like the way it reads them in, is as an XLSX file. I don't know why they added that on, just their prerogative. So we're going to see if we have that file on our computer. It's going to look basically the same. XLSX, there it is, found it. And I think it already opened. Nope, here it is opened. Oh, it doesn't put the, oh, it actually has the bolding on the column names. I'll show you. But it bolded the column names for me now. And it didn't put the leading number of 1 at the start. So you can see the difference between, I stored it as an XLSX file and I stored it as a CSV file. The CSV file put a kind of row number right here, didn't bold the columns, where the XLSX file bolded the columns. It also centered the text. Interesting. I reshaped it so a little more space. But that's the ease of writing your file or reading your file, because now we could actually go to read XLSX and we could read in the iris, which this is just reading back in a file we wrote. So that'll read in the file, and then we could say here, save into data. And now we've stored it as data. Learn these things in little bits. And then load our data. What do we do? And it's all about understanding the basics. And so really, R is one of our primary components. To answer Marco's question earlier, in C++ reading in a file took me like 12 hours to write this. Yeah, no, you just say, I want to read in this file. Like, hey, what's the name of the file? You have to give the file extension. The reason I'm using this right here, and I'll show you, you would have to go read CSV. I think CSV2 might have some small differences. I can't tell you the difference between the two of those. Iris.csv. And so now I just overwrote it. like it's not really making it. We call this data 2. And there you go. Because now I'm using the read.csv. What does read.csv do? It reads in CSV files. Like it reads like a book. And then if you don't store it, it'll just read it. So you don't want to just read something. You want to read it and then save it into. Funny enough, I usually don't store with right arrows. The directionality of the arrow shows which way it's going into. I usually do left arrow save intos. But the left or right arrow, rock knows. It doesn't matter. You're just storing into that object. Like everything I'm doing right here is storing into data. I think a lot of people are used to reading from left to right unless you read manga. Sometimes I read manga. But this says read this and then store it into this object. So that's how we would say like read in this file. So read Excel files, this file specifically, and then store it into this object. And that's what the left arrow is doing. It assigns the object data to be the read-in file iris.xlsx. And I try to tell my students this, that when you're coding, you've probably seen this, Jack, you want to try to read it as a sentence. Like, could I read you this as a sentence? Read in an Excel file. The file we are reading in is the iris.xls file, and then store that file that we've read as the object data. So it'd get very complicated as we build our code further, but you should always try to read what you're doing as though it's a sentence. And the easiest way to say is I'm just creating the object data that is the read-in file Excel iris.xlsx. Because if you don't know what you're doing, then you're like, I don't know what the code does. I can't fix it. I don't know what it does. But yeah. You want to see something crazy. Yeah, it's scary at first. You know what's really funny? In 320, a lot of people are usually scared, and I'll try to tell them this today. In 320, a lot of people are usually scared about the coding. And then by the end, they're like, no. Memorizing the concepts is harder than doing the code. Because here's what's really cool. I'll show you how we do a regression in 320. So if any 320 students watching this and like, I see like half my class drops today. Like I go to class, like, how's everyone doing? They're like, we all dropped. We saw you during office hours, Brian. We're out. So Iris is the Excel spreadsheet. Does this make sense right here? Like, here, I'll clear the global environment. So I just took everything out of the brain of R. This is kind of like a data set that always exists, even if we don't see it. So I'm just going to store it. It's like a freeware game that is always on your computer. It's a base R. We call it base because it's there at all times. So I'm going to store the Iris data set. Let's go even easier. MT cars is a car data set, which is always here too. So there's the MT cars data set. These are different cars, like the Mazda RX-4, the Mazda RX-4 WAG. I have no idea what that even is. We have different variables, like quantitative variables on how many miles per gallon, how many cylinders, all these different things right here. So we have all these data on these different cars. Now, when we do this, we need to learn just a few simple functions to basically complete 320. The more we learn, the better. So we probably need to know a function called LM. LM stands for linear model. If we're making a linear model, we probably need a what and a what. Jack, 20 points right here. Feel free. Don't worry, say I don't know. I'll probably answer the question too. What kind of things would we need for a linear model? Like if we're going to make a linear model right here, what do you think we would need? A what variable? And I'm only looking for one letter for this. And we need a what variable to make a linear model. So what variable names, think of only one letter, do we need to make a linear model? And it might actually show it when I do this, saying formula. So what formula would we create? We'd have to put in something and something else, and only think of one, so I should only put maybe one dot. Like something, a blank variable and a blank variable. And so like we would usually have a this variable over here and a this variable over here. So we'd call those variables what? We'd have like a this variable, like a name for it. Like, okay, wait. The first thing I'm putting in for my formula would be this variable over here. We'd call this the blank variable. And just only think of one letter. And then over here, we've got this right here, this variable right here. And so I'll answer in a moment. But no, I appreciate everyone following along or just trying. I've only got like one or two people here, but I love it. We have a Y variable and we have an X variable. So this is just like placeholders for the moment, but we need to figure out a Y variable and an X variable. So I'm going to see if miles per gallon is what I want to understand. Can be explained by the horsepower of a car. You know, like cars that can really tow things might have worse miles per gallon. That's kind of what I expect. I mean, I haven't looked at it yet. Now, when I run this, it might run or it might not run. It doesn't run. It says it can't find horsepower. It's looking right now here. It's saying, where's horsepower? And it says, I don't see horsepower. And the answer for where horsepower is, and if I had like 30, 40 people watching, I'd pause and make sure everyone answers. But horsepower is inside of where? Horsepower is inside of MT cars. So if you look at the way the function works, we have an argument called data. So we already put the formula in. There's the formula. And then we have an argument called data. Arguments are just more instructions. It's like I say, make me a pizza. That's argument 1. It doesn't mean I want pizza. Pizza, argument 1. And then you say what time. 2, the second argument is what time. Or you might say what toppings. There might be an argument for toppings for the thing you're creating. So we're going to go here and go data equals, and we're going to go empty cars. Notice how we have autocomplete, which is nice. And now let's run it, and it created a model. Remember, in regression, if you've done 201, that we have an intercept, B0, and we have a slope coefficient, B1. So we actually just got a model. But here's the thing. We just kind of put it out there into the ether, like we did when we were reading a data set and we didn't store it. So whenever we create something, we usually store it. And I usually store these into M, which stands for model. You can call it whatever you want. You can just go M, whatever you want. But we just go M right here and create a model. So this created the model. And if we look at it, it'll show us the exact same thing. But now we can manipulate this object. And what do I mean by manipulate? Well, we can put it into a summary. And now it gives us a summary of the model, more traditional for what we see in statistical analysis, where we still see the same intercept and the same slope, but it has things like the uncertainty, the standard error. We also have the t ratio. Remember that from JUMP, the t ratio? Well, that's a standardized test statistic to tell us if the slope is statistically significant. And from 201, the significance of the statistical model when it comes to a regression is the significance of the slope. That negative relationship I expected to see where cars with higher horsepower are expected to have lower miles per gallon actually exists. But this might not communicate that idea well to someone. Rather than showing them the coefficients in the model, I can just go to visualize. Oh, we don't have reg class loaded. Reg class has our visualize model. And so now when I type visualize model, it'll autocomplete because this is a function inside of reg class, which lets us visualize the model. Let's make it a little bit nicer to see because it's kind of, we're getting a block on the screen on that. I can actually remove that for the time being because we're not going to talk about confidence intervals. There we go. I moved the location of the output so it's off the screen. Oh, and you notice there's a non-linear relationship. You notice right here, QQ straight enough, no outliers. I see right here a bend in the model towards the end where you kind of get, you can't have a car that gets no miles per gallon. As you approach really high horsepowers, you are approaching very low miles per gallon. So what if we went over here and did choose order and we look at the polynomial models? So now you can see that there might be sort of a polynomial bend to the model. This is what we do in data analytics is we ask the questions, like maybe there is some sort of like bend to the model. And then through 320, we can look at the analysis over here and we can say, okay, look, probably the easiest thing to do is look at the Ake-Ike information criteria. And this is the corrected, it's got the extra C, the corrected Ake-Ike information criteria. And the one that is the lowest is right here. So since this is the lowest Ake-Ike information criteria, also has the highest R squared adjusted, more on that in 320, we can go back to our original model right here and maybe make a second model. So we go here to model 2, where instead of doing horsepower, we do the polynomial of horsepower. So we go here to poly, which stands for the polynomial relationship, and we choose the second order. Now, this is looking a little bit complicated now because we have an x variable that is inside of an argument. This is the x variable horsepower, but we're bringing it to the second order polynomial degree, which we see right here. So instead of just using the x, we now have a model where we have a y variable, miles per gallon, and we have the x variable horsepower, but it's being done to the second polynomial degree. So now we've created that model, and let's go here to visualize. I think it can visualize. Please visualize. It won't. No! We did make that model, though. We could view it a little bit better. Let's go to max order equals 2, and that's the model we created. So this is the model where it might be overfitting a little bit to this guy, but it does look to kind of peter out. I wonder if I could remove that linear model. You know what? We're gonna have a little bit of fun right here. I like to challenge myself. So if you're watching right now, that's kind of, this is towards the end of 320 right here. This is, 60% through the semester, we'll be talking about polynomial orders for models. We do start with a review of Tool 1, and we tell you how to code, and we start from the very basics. So if you can tell, this is a very versatile platform right here where we can create graphics, we can analyze data, we can figure out what the best models are, and we can have reason to say there is a model that explains the miles per gallon that a car gets based on the horsepower. We see kind of this kind of polynomial relationship that there's kind of a decrease to the horsepower, the decrease to the miles per gallon based on horsepower, but there's kind of a leveling off towards the bottom right here. Like it doesn't constantly go down. Cars with very high horsepower are kind of in a group. Like it's pretty flat across here. There's something actually called piecewise regression, which we didn't use here, but you could create multiple lines and use pieces of regression to explain this. So that's actually another technique. And there's just endless techniques you can use. What technique is best? As we say in 320, all models are wrong. Some are useful. So who knows what answer is best? Everyone's going to debate in statistics of like, I think this is a great answer. What I'm going to do right now is going a little bit crazy because I want to create this thing right here, which he's probably using. I want to see what he's doing. So what I'm doing is I'm viewing the function Dr. Petrie created. We're going to write again. And here's the function Dr. Petrie created to create this graphic. So we can take Dr. Petrie's function right here. Dr. Petrie, great coder in our department. We're going to take his function. We're going to bring it over here to a new script, and let's take a look at it. So where is he graphing it? It looks like right here, and he's probably doing it in a loop. We won't go into too much detail on loops. If the head of the class, so he's checking to see if it's a linear model. So he's looking at the class of it and looking at the first thing and seeing if it's a linear model. And so then he's going to say, if it's not linear model, that stands for is not equal to linear model. Okay, and then he's going to end his function. Return ends a function. He's going to put this out. So if we were to put here, so just to show what this is doing, I've never actually run into this error, but if we do this, he says argument must be a fitted model, and then returns null. We could do this. Hi, Brian. And we would need to restore this. Let's go choose Brian. Just to show we're manipulating this. Choose Brian. I've made my own function. We put 2, and it says hi, Brian. So that's what I've done right here is you always want to understand what your code is doing. If you're in 474 or 475, this is where you want to be at. Like we want to get our students to understand what these things are doing, what that's doing, and how you could manipulate it. I haven't really broken anything in the function, but Dr. Petrie has this right here saying argument must be a fitted model. I put in there 2. 2 is not a fitted model because it went and looked at it and said that's not a model. And so it said if it is not a fitted model, then print this to the screen. That's what cat does. So we got the print to the screen right here. And then the return actually ends the function. So it literally says function over, you're done, we're leaving, and it says hi, Brian. So it also does this, like it returns whatever we have. So now he's storing the names of the coefficients into the object V. This is similar to what we were doing earlier. I'm just having fun. If you drop in with questions, let me know. You're like, Brian's already coding on the first day. I like kind of testing my knowledge here and looking through his code. If the length of V, okay, cool. This function is valid only for, okay. So what he's looking at right here is he's looking at the coefficients for a model. And overall, this seems quite similar to, yeah, I know, right? So do you see right here, he's going to look at the summary of this model and how many coefficients there are. And if it's greater than 2, this function is only valid for simple linear models. So let's go back to here, create our polynomial model, M2. So when I run choose Brian and do M2, it's going to say this function is only valid for simple linear models. So that's where that is coming in. And why did it return that? Because if you look at how many coefficients there are, M2 will have 3 coefficients. So since this only has since this has 3 coefficients, it has greater than 2. So if there are more than 2 coefficients, so what we could say is not equal to 2. That's another way of saying it. Like if the amount of coefficients is not equal to 2, then return this error right here. Or it's actually doing a stop, which also stops the function 2. We could also just change this to, see, this is like the small nuance of it. Let's go to choose Brian and show it again. Choose Brian. So this returns it in red right here. If you make it a stop, the stop is going to make it a red message. But if we make this a return, it's going to return that as a character, which really we wouldn't want right here. Did I not update it? What's going on? Oh, no, wait. What did I not? I just thought I changed something. Oh, I changed that one. There we go. And this is the small nuance like Rock knows.
It doesn't matter.
And you see now it says it that way. To the previous time, it did it as a red arrow, which is probably going to be more eye-catching to our viewer when they see this arrow appear on the screen, because it's saying you should only have two coefficients, an intercept and a slope. So that even goes back to 201 knowledge of like, okay, wait, this is only going to use a simple linear model. If you give it a polynomial model, which has three coefficients, it has the intercept and then has the coefficient for the linear term and a coefficient for the polynomial relationship, then it's going to return to you an error. So all we're saying is we want a slope and intercept in your model. If you give us a slope and intercept, which is, we can even use choose Brian right now. So this model right here has just a slope and intercept. I'm using the linear model. It runs. If you say use a model, and I'll clear the output so you can see that it's going to fail and not return anything. If I give it a model with three coefficients, then it's going to say nope. And we made it not a red error message. We made it just a text return, the red error message, by going to return. If you want to make it red again, you go to, and so now it does the red stop error. Okay, let's look at the next portion of the code. This is good. Truthfully, I'm half doing this just to practice myself and see if I can uncode all this. Okay. So this is where he stops his function if there's an error. Here, he's going and he's taking the model from, so the model right here, this $sign, goes inside of the list. So when we already have a model stored, so he's going inside of his model right here and storing the model as data. So he's taking this information right here. Oh, so he's actually taking the X and, no, I'm glad, Jack. This is neat. I'm so glad Jack points right there. I'm glad this is, it's like, what is going on right here? I love looking at it. Like, this is fun to me. Like, if someone's like, what is he doing? This is fun to me, like looking at this and being like, okay, he's storing right here. He's taking his X and Y variables. So he's just taking from the data only the X and Y vectors. So you can see right here a small Excel spreadsheet, and then he's storing that as data. Then he's going inside of the data and he's ordering it. I might need to run this. Let me take a look. He's ordering it. I don't know why he would do that. And then he's storing the X and Y as only things because he's taking, this is row and column. But why is he doing, what is the point of this? So we're just going to run his code because we already have a model stored. And then let's take a look at what it did. Just order it? Well, that's, okay, let me look here. So he's ordering, this is the order of them. He's ordering it based on the second. I don't know why we would need that. So if you look at the second, yeah, hopefully I'm not scaring anybody. He's ordering it based on the second variable. So whatever the second variable is, which is probably, since it's usually y tilde x, I think we were predicting miles per gallon from horsepower. He's ordering the data frame on the x variable, which is what I thought he's doing, because the order orders the data frame. So it's going to order everything right here. It's literally just the same idea. Is if you were to go to the data and click it and just click here, you could order it like this. But this is not going to store it. If you notice right here, this, like, it's just sorting. So I know you would think you would use sort. It actually, you have to use the order function. That's probably one of the confusing things. So he's just literally sorting his data. And then after he sorts the data, which I don't know if this is needed. Like, I'd have to ask Dr. Creature, why would we sort the data? It's not a bad idea. Put your data and sort it. He then takes the first column. So what this does right here is this says take all the row space. This is everything. So this is everything here, because if you put nothing, it's everything. Kind of weird, right? By leaving it blank, you're saying, just take everything. Here I can take only the first, or I could take the first 100. That's a vector of 1 through 100, and that would take the first 100 rows, not even 100 rows. But we could take 32 rows. But this right here for this data set would accomplish the same purpose because the data has 32 rows. But rather than putting a defined thing here, we'll just put take everything. So take everything of what? Of the first column, store that as the y variable. So it's going to take all miles per gallon, store that as the y variable. Take everything from the data set again in the row space, and then take all of the second column. So this is where he takes this column right here and stores it. And once again, we can view this. This is what I like about storing these, is you can see right here, if we run y, it's all of the y variable and it's all of the x, and he's just taken those vectors and stored them outside the data frame. So if length of unique, okay, so here he's checking if he can actually make the models. if the length of the unique, so what unique does is it sees how many unique values there are for something, and he's seeing if it's less than 2. So like if you have a vector right here of like, and this is how you make a vector. Oh, let's do this. That's kind of Jack. How many unique things are there in this vector? So here's the vector. We can make it even better by just calling it vector. So how many unique things are in that vector? Pretty easy. Like how many unique things? Like if I say like, oh, give me one of those things, you'd say, well, you only have this many choices to like, just look at what's in that vector and be like, how many unique things? So I can go and run this and answer the question for you, even though we can kind of see it. How many unique things are in that vector? How many unique things would be in that vector? So, well, go grab me one of those things in the vector. And I say, well, you only have this many choices between them. I mean, you do have 1, 2, 3, 4, 5, 6, 7, 8. So you do have 8 things. There's 8 things. And the unique values, this will actually return the unique values first. And we can see what he nested length unique. So there's only one thing to choose from. And so what this will return, and we have to know what it's going to return, is this is going to return 5. So this is going to return 5, not because there's 5 things, but because 5 is the only unique thing. So it's telling us the unique things in that is 5. 5 is unique. But if we go to length of unique, that's going to tell us how many things are there. And there's 1. So let's change it. Let's put 8. Now when we run right here, unique. Yeah, I'll tell him we did like a whole, and then we do length of this. Yeah, that'd be great. Does that make sense right here, Jack? Like now I have a vector with those things inside of it. It's just like a box with 5, 5, 5, 5, 5, 8. And I ask you, what are the unique things inside the box? You say, well, there's a bunch of 5s and there's an 8. So I'd say, well, what are the unique things inside this box I created? We can just literally call it box if we want. Here's the box of stuff, box o stuff. Inside my box o stuff, tell me what the unique things are. Oh, really? Box o stuff. And the things inside my box o stuff are a bunch of 5s and some 8s. And now right here, let's go to how many things there are, the length of the unique things. You could also tell me the length of how many things are in the box of stuff. And there's 8 things in the box of stuff. So understanding what the codes do is most important, because now if we say how much is in the box of stuff, you can actually, there's 10 things. You can see it up there also. There's 10 things inside the box of stuff. If we ask how many unique things are inside the box of stuff, this is how many unique things are inside the box of stuff. There's 4 unique things. You can see it. And what are the unique things inside the box of stuff? A 5, a 10, a bunch of 5s, an 8, a 10, and a 110. You could also do this. Last thing I'll show on this. You just make a table of it. So there's lots of ways to get these answers. That's why we want everyone to think of like different ways to do things. You'd be like, oh, there's 4 things. And you could go to length of table for box o stuff. This should get it there. There's 4 things. So how long is that table? How many things are in the table? Table might be one of the best ways to look at it, because then you could see there's 7 5s, 1 8, and you can literally look at my box of stuff up there. So what we try to do is we try to understand multiple ways to do code and try to read it and answer questions by like how many things are in this box, how many unique things are in this box. And that's what Petrie's doing right here to make his function. So now, let me look at when's my next class. I think 150, right? Oh, we got tons of time. I sent out a 30-minute announcement. 475. Cool. If you don't have these 2 things, you need at least 2 points to continue. So he's looking at how many things, unique things are on X. Now he's taking the number of rows in the data frame. Okay. So he's figuring out how many rows there are, which would be 32. Awesome. Have fun at that haircut, Jack. Thank you so much, Jack. Some points. I'll continue to talk through this and make sure I understand it, and then I'm going to try to do a plot with it. I never use this ... Does that mean continue the format? Oh no, there's something I don't know. Let's see right here. Does that mean like continue the format? There's things I don't know. I don't like it when I don't know things. I try to learn them then. He's creating blank vectors right here. If you saw my vector format from earlier where I created a vector, concatenate creates a vector. If you put nothing inside of it, you get a blank vector. So he's creating blank vectors right here, just like null vectors. It means nothing's inside of it. It's just, he's creating a space. Like here's a blank space. There you go. Taylor Swift would love that. There's a blank space right there. And we've got r squared adjacent is a blank empty space for us to work in. The vector A, amazing. I think that's the R squared. No, I don't know. He made A. I know R squared adjusted. I say adjacent. R squared adjusted. That's what ADJ is. He's changing his window right here on how he does it, or he's confirming that it's going to be one row, one column for the output window. That's a global thing to change the. I forget what MF row means, but it controls. It'd be good if I remember the acronym, but that controls the output window right here. So because he's creating his plot next, and the X labs right here, which I really should learn this format. Like this is the one thing I actually do not know. And the max order, this is what I was controlling. That's the function he put up here with max order to control the max order, which is auto assigned to 6 right now. He already has a max order assigned to 6. Here's the real meat of it where he gets into the for loop. So he is running a poly to degree I, and he's going to run his for loop right here, 1 through the max order, and he's going to run the poly right here. And then he's adding a lines. That's all you have to do. That's all you have to do. So is the only thing we were looking for, really. Lines X, fitted model, color is this, line width 2. So that's controlling the line width. So this is all we wanted. This little thing right here is what we wanted. So let's go ahead and go to our M2 model and we can actually make it. All that work to just see how he did it, but it was worth it. And so now lines of X, what's stored into X? Y tilde X. Okay, it's the X variable. So there's no Y variable? Oh, that's why his Y doesn't have a name on it. Oh, is that why? Because I noticed that in the choose order, it didn't have a name. So, ooh. Need to put that Y-axis title on that. I need to make it in Plotly. So we need the name of the X variable right here. It was MPG, I think. No, it was horsepower. Oh, no. Horsepower not found. Okay, cool. Because it's max order. Where is he calling the data frame? Plot. Okay, wait. So I think he's already made the plot, and then he's fitting it to it. So he's already taken, that's why he's not calling a data frame. He's already stored his vectors to the global environment. So we have to go and take our vector and store MTG cars, horsepower to the global environment. And now we can run that up. Object I not found because I is a placeholder. So call equals red. Nope. Plot new has not been called yet. Yep. So we got to make the plot. There's the plot. Let's store MTG cars. He's a lot of work. MPG. Store that to global environment. And so now we have the plot. MPG. Horsepower, X labs. We're probably good not to include the X labs. We're probably fine on that. There's the plot. We got our plot. And now lines. There we go. Oh, no, it's only that's not the second order. Oh, because can we just fit this? Can we just fit this? Oh, will it work? Will it work? Will it work? Oh my gosh, what have we done? I love coding. What did that do? That's ridiculous. Wow, I'm having to think through what this did. It's like a kindergartner made it or something. Sorry, kindergartners. So that's draw me the polynomial model, and we got a very interesting relationship right here. Does not look to be quite. It's something. So why did that not do? We do have it fitted M. Still using the M right here. But no, it fits the model to a polynomial relationship. Oh, I would have thought this would have worked. It's going to loop through and add the lines each time. I have poly 2 stored in it. Now this is what's confusing to me. Let's look at this poly 2. That is a second order polynomial relationship between horsepower and miles per gallon. And should we have done this? No, he's not. Is he using max order in here? You can oh no, that's the max order. That's not going to matter. That's him telling this how long to run. This is all that matters because this is where he's adding the lines. Color's not going to do anything important. Brian is trying to figure this out. This is Brian's office hours for Brian's right now. Brian's trying to figure out, why did my line turn out all crazy? I'd love to fix that. Could it be the plot? No, that's just all I removed was the X labs on that. All I removed was the X labels. Why did it do that? Craziness. Should be fitting the relationship. Let's grab the code verbatim and try it. Let's bring it over to a new sheet and drop it here. Okay. So we got max order. Let's store max order. What we're doing is we're running the function outside of it. So we're going to store max order 3 and see if we can do this. We do have HP stored to the goal. Ooh, I think I figured out the problem. Rewind the tape. I said, why does he sort the vector? Why does he sort the vector? I think this is the problem. So what we need to do is we need to do that preliminary work that Dr. Petrie did to sort the vector. So we have the data frame stored right here. He just calls them X and Y. I think we still have our data stored as X and Y. Okay, so we're using the same names as him. We've already got a model created here. Let's go ahead and we might be able to really quickly do it because we're taking our model right here. There's the model we created. There's the X, there's the Y. And so now we have the same XY names. We have max order 3. And let's remove the plots. And we need to call new plot. He does that before. So we need to create the plot first. And there's the creation of the plot. And there's the creation of the plot. And now we didn't get non-numeric K. Was it because he created K beforehand? Let's remove all the AIC stuff. It looks like crash. Okay, there we go. We are getting it. Good stuff. We have created it because I think the objects, we were trying to store in things that didn't exist because we took out those parts. We're just trying to get his plots. I think it was the ordering of the variables. That's why I questioned, like, why are you ordering the variables? I think the way he's doing the points and defined how it has to go through them, you have to do both vectors ordered. And that's the way he's creating this relationship, is ordering them and doing it in the order they appear to create the polynomial relationships. Well, we found out why that was important. You know, why do you do this? Well, you need it. That's why. And so if we only wanted the poly relationship, and so watch this here. We're going to create our own function. This is the whole goal of this. This is the whole goal of what we learn, is to then take something like Dr. Petrie's created right here and use our own thing. So let's say we're going to go and just do the second order. So if I run all my code right here, we don't need max order anymore because I've already changed this. We really don't need a for loop, but we'll ignore that for the moment. Let me remove this because I think it's just over plotting. X and Y have different lengths. Ooh, that's bad. What did I do? Really? Really? Why is it mad? I love code. Now what we're going to do, because we broke something, is we have to find out what we broke. That's not broken. That's not broken. Oh, here it is. It's mad about this. Why is it mad? Oh, my. Oh. Oh, I think we're using a poly model right now. I think our model is a polynomial. Oh, this is, woo. Okay. We need to store that's, yeah, we broke something very quickly. MPG tilde HP data equals empty cars. Cool. Okay. Okay. Not broken anymore. Oh, you know why? As you run this function, it overwrites what M is. So the reason we broke it when we reran it is because the function was overwriting M. So to be safe on this, we're going to call this M2 and call this M2, so that when we go up to here or we rerun this, it's not going to have the same problem, and we're good. So because we were calling it M, it overwrote what we were using, and then when I reran it and it tried to use M, it had problems. We only want to go to max order 2 right here, but we're not even going to do it. We're just going to do a poly model. Let's clear this. Let's run this. Let's see if it does it, and we get the polynomial model. That was the whole goal of all this. Whole goal of all this is we're going to go graph polynomial, and we're going to make our own graph poly or graph. What is this called? Parabola. Let's call it graph parb. And so we got right here this. And I wonder if we can return all this. Yeah, it should just do the plot, right? It should do it. Okay, so we've got our linear model created. We're storing the X and the Y. It's taking from this. I can't even think of how many things I've broken. Yes, Rose, 20 points right there. Yeah, it's exactly it, Rose. Thank you so much for swinging by, Rose. This is, we're basically to the last step, Rose, because check this out. You ready? We're going to take all of it. We don't even need max order anymore. We're going to take everything we've written right here that works, and we're just going to go to function, and then we're going to go to graph poly. Ooh, I hope it works. And graph poly will take M. That's all it takes. And so there's our graph poly function. And if this works, we should be able to go over here. And here's the big test, the big moment of truth. If we go to M save into LM, and we go to miles per gallon tilde horsepower data equals MT cars. Now we're creating our model, and we go to, we don't have our graph poly function. We actually have to store that. There it is. So now we go to graph poly. And if it works, you ready, Rose? 3, 2, 1. Woo! We've done it. We now have a function, Rose, that will graph the polynomial relationship between any two variables. We have created the graph poly function right here, and we can now graph polynomial relationships without running a bunch of code. So we could look at any of the variables inside of here, like the disp or whatever we want, and we can easily get that polynomial relationship. Boom, beautiful graph right there. And that's the polynomial relationship. We got it. We could even change this so quickly. Oh, you know what we could do, Rose? I got such a great idea. Check this out. We can now put a second argument right here for the graph poly, and we could say order equals, and let's say 2 by default. And then right here, we'll call this order. I love this. I'm just sorry. I get so excited. I feel like I'm and so right there, we got this. And check this out. Graph, and we'll call it graph poly, which we did. So now when we run this, we can do this, or we could put order equals 3, and bam, there you go, Rose. We can now change the order to this pretty easily and look at the polynomial relationships with this graph poly, and you can just go crazy and choose whatever order you want. And that is the goal of this. Really makes you see, oh, send it to me. Rose, send that to me. Send that to me as soon as possible. And this is the ease of creating functions. Like once we create this function, we make our own custom function right here. It's like, oh, let me look at the linear relationship of this. There's the line. Let me see what the polynomial looks like. Let me see what this looks like. And we could graph them all. That's what choose order does. But if you wanted to see one individually, we now took the code from Dr. Petrie, isolated the part that does what we want, and then put it into our own function, like Dr. Petrie did, that creates what we're doing. And this is, I don't know, this could literally be a mini assignment for students. I would expect this with like 474, 475 level students. Rose, on a scale of 1 to 10, like 1 being like that's a joke, 10 being it's impossible, how hard do you find what I did right here by taking the code, kind of putting, for loops were already built. I went into Dr. Petrie's code, I isolated what I needed, I found where he did what I wanted, I ran through it, and then I went here and made my own function, which I stored, and then I can just use that function to make any sort of relationships. I'll have to look back and find what, yes, please find it so much. Yeah, definitely send it. Send it right away. But this is kind of the fun of coding to me. It's like, once you get your thing created or what you want, you can then manipulate and work with things however you want. Like I can pull up another data set right here. So let's say I'm investigating students' heights and weights. Not that we ever look at survey 10. Survey 10. It'll be there. Yeah, the loops are the most difficult thing. I'm not even really utilizing the loop. I'm kind of like, it's got the placeholder, so I could technically remove the loop because we're only really running the one time through it. I'll leave it for now. I guess you could give it a vector. Oh my gosh, watch this, Rose. I got to see this real quick. If I do order Look at that. You can actually choose multiple things right here. You could compare the line to like the 6th order. So you can actually utilize the loop. So keeping the loop there is kind of cool because it'll create both plots. And you could see if you could compare models right here and do a model comparison. You don't have a metric like AIC or R-squared adjusted, which we should have, but you could go and take just those components right here and visualize just the first order model and the 4th order polynomial relationship to see if there's any sort of additional variation explained by R-squared. Now, oh, wow, that was weird. There we go. So you can see there is kind of this, there's a bit of a 4th order. We don't have the diagnostic statistics for this, but visually you can see there's something. There's something. But what we should be able to do is we should be able to take our model and just go height tilde weight. Not that we ever do this. Yeah, exactly. Such a nice way to be like, here, let's take a look at this. Let's take a look at this. And that's what people want to do is they want to compare models. Let's compare for our models now, the 1st order versus the 4th order. And there you go. This is the thing, Rose. It works on all of them. We don't have we could add in the column headings like Petri did, but now we're comparing a 1st order model to a 4th order model on height versus weight, where we really might say, let's just go with the 2nd order model or something. But you can compare the linear models to other models right here and see what's going on. You can even go crazy and do something like that. That's going to be overfitting. Please take 474 or 475 where we talk about overfitting, where we go too high with our polynomial order or something like that. Like, that's a bit ridiculous. You might say, well, Ryan, just why not go up here and go to like, yeah, it's mad. Oh, because there's not enough unique X's. 35th. Oh, it's mad. Really, there's not that many unique points? I call liar. There we go. We can only go to the 20th order polynomial. Yeah, I do. I appreciate that, Rose. We really try to have some good structure and follow students through a kind of like set. Here's what to learn. Here's what we're trying to understand. And we're trying to, with the business analytics courses, because Marco kind of started this conversation, we're trying to grow a skill set in individuals, grow a skill sets to, like, none of this was a assignment I was doing right here. Truthfully, the creation of this right here would be something to help me analyze data. And so if you work for a company, you might say, well, let me make a function that lets me look at these models and compare them. You could even prompt the user. So watch this. Let's go here and go to, we're going to change our function real briefly. Watch this, Rose. You might not know this. Read line. Okay, read line. And let's say, what is the name of your model? Okay, I think I'm just like afraid when I do this. Read line prompts the user. We'll say often M. Okay, so I'm thinking, because now we need to ask them this. And then we're going to store, but I'm thinking if they prompt it as M, let's call it model. And I'm just like afraid. I don't use read line so much, but it will ask them, like, and then say, what order do you want to raise this to? Actually, you know what's even better? See, that's going to be a bit of an issue. We could say, so let's go here, order, and go to 2, and then we're just going to overwrite it. Why not? Let's go here to order equals as dot numeric, because they need to enter a numeric value. Read line, we're going to ask them what the question is, and what order do you want to see? Okay. So now when we run this, got it same. Okay. So now the function has changed a little bit. I can still, it's going to get mad if I do that. Okay, cool. And we probably, cool, it's got 2 as default. Okay, well, let's remove the default. We kind of can't override it. And so it shouldn't be an argument. Okay. Ooh, I have capital order. Let's make it lowercase. Oh, wait, that's an order function. Oh, how did I not? Okay, I think we're good. And we don't want that here anymore. Okay, so we changed around our function a little bit here. So now the function will now ask someone what order they want to see. So what order do you want to see? 2nd order, and there you go. So now it's maybe a little bit more user-friendly if we tell people you just put the model in, you tell it what order you want to see, and it shows you that order. So this is where, designing it comes into play. Like, what features do you want? 475, right? How do you want this to interact with the user? We could put checks in here. Like if someone doesn't put in a numeric value, then it might just break. Let's try this. Nope. Well, it breaks. That's fine. We could put in a custom error message that if someone puts in a value that is not numeric, it'll probably, and it's getting mad right here, which now we got to fix this because someone's going to put in something that we don't want. So let's go here. Oh, so we want to probably go here. Read line, do this. If order is dot numeric order. Okay, that'll see if it's numeric. If it's not numeric, stop. Please only enter numbers 1 through 20. And then we go right here. And after we've checked it to see if it is a number, we're going to overwrite order with as.numeric, and we're going to turn it into a number now. That should fix the issue and should give them a custom warning message. So now we ask them, what order do you want to see? They say 3. Oh, it's mad at me. Because that's, I think, an integer. Let's go as is.integer. Your integer and everything. Let's try it again. Oh, it's still mad at me. How is it not seeing that? Is dot. Let's go here. Order. Class. It's numeric. It's not. It's numeric. Is dot numeric order. It's true. If we had a not before that. Oh, the read line takes it in as a character. Read line first sees it as a character. So when you do read line, that always gets me. If you go 3 right here, it sees it as a character. I ran it twice. So it's going to, oh, that's asking the question 3. So enter a value. So if you put something in here, it's going to see that as a character, and the quotes mean character. So it is seeing it as a character. What if we go, let's try this. I'm just going to do a quick thing here. So let's bring this up here and go here and is dot numeric. Cool. Let's just see what happens. And so let's run it. 3 works. That's the same graphic we're getting. 4, different graphic by my head. Now let's try to break it and see if it works. J, and there we go. It's still giving this error, though, not my custom. Oh, did I not have the custom error message in the right order? I see. How does it do that? Okay. Warning for the class. Let me send out the announcement. 475 announcement coming right up right here. Okay. Brian has fun in office hours. So it's office hours for Brian today. Well, gotta log into Canvas. Okay. I want to get this to work properly. And this is just how you practice your art. Whoa. Whoa. People have already completed 475. Oh, this may be the other section. Announcements. I'm section 1. I'll make sure I got the right playlist. Cool. Announcements. Class in 30 minutes. Link included. Okay, section 1. See you soon. Click here. I'm pretty sure section 1 is my section. Link. There we go. I'm going to double check. Make sure it's my section, because my section shouldn't have a lot of assignments completed yet. I think I'm section 1. It looks to be. Looks like section 2 has done a lot more of their work. Good. We'll get everyone to do their work today. New announcement. Okay, I got section 1. There we go. Okay. Announcement sent out to all the students. And can we fix this in the moments left? Can we fix it? I want to fix this. When I go here and go to save into value, and I go read line, I go read line story value. And then we store G. And now we go to value, it's G. And we go as.numeric, and we go to value. Oh, and it stores it is NA. It's storing it NA. Okay. So if we try to convert something that is numeric that's not able to convert, or something that's not numeric, we're going to get NAs. NA means missingness. So what we then want to check right here after we convert it, we're going to do is.NA, and that should catch it now because it's going to make it an NA. So that should, and we're just seeing what happens right there. So we go here to this. We say 5, and it gives us the 5th order. We go here to this, and we say J, and it says, there we go. Error, please enter a value 1 through 20. In addition, warning message. And so we can maybe put a suppress warnings on that. I'm too crazy. I like my things to look perfectly the way I want them to. So it's doing that when it's doing the, so we're going to add a suppress warnings right here to take away those error messages. Suppress warnings. And that should fix those error messages. And this is how you make custom functions. Works on 2. And then we run the function again, and we put in J, and there we go. Now we just have that one error message that we want. Error in graph poly, please enter only numbers 1 through 20. And this is and so if you saw this and you experienced this and you're like, I'm scared, we always code, and Rose probably knows, in little bits. If you watch how many times I ran my function when I was doing this, there's endless rerunning the function, rechecking the function. There's where I accidentally was finding out I was using the poly models. But I'm rerunning the function at all times. This is kind of how we code, is you don't code it all at once. This 20 lines of code, little bits, Rose knows. 20 points, Rose right there. Don't code it all at once. Don't sit down and say, I'm going to get this to work. You have to say, why is this not working? Why is this breaking? It's basically a big logic game. It's like a puzzle. And you're like, what way do I have to turn this? And I think that can drive some people mad. But when it works, when you get exactly what you want, you're like, yes, it only displays this message right now. And so I didn't want it to also say NAs, like they're like, NAs are produced. Why is it telling me that? All it's telling someone is, please only enter numbers, and we could fix this now. Please only enter numbers for order between, and then we could say this. So now we're just changing that error message. Found the names of the package, Rattle. Yes, Rattle is so good. It is used for GUI and data science, the graphical user interface. Yeah, Rattle. I need to work more with Rattle. Rose, if you have code you want to send me, I do have library Rattle on here. Should have Rattle package. And you can view what's in this. So Rose is saying there's a bunch of really cool functions inside of Rattle. There's, what is it called? Don't tell me. Pretty, is it pretty? No, it's not pretty. It's fancy rpart plots. Those are really great there. Is that what you were using? Those are really great. The Rattle package with fancy rplots, rpart plots is pretty nice. Easier to visualize the trees. Problem you run into with trees sometimes is some of them are so big that even fancy R plots is gonna, the fancy R plots is really nice. Great job, Rose, right there finding this. Good searching online, finding this. And all you have to do is put inside of this your tree. Now, we don't have a tree right now, but if you make a decision tree right here, you would get this, which we should be able to do, right? Let's go over to rpart. Let's go over to rpart in the formula. Let's go here to, let's predict the MPG of a car, tilde, dot, which means all the variables, data equals MT cars. And there's our tree right there. So we got to store it. Let's store our tree. We didn't do a CP. We could use a CP. And guess what? That's how easy it is. The mini split in Maxbox. Yeah. The min split and the maximum, like controlling the parameters about what will go into the tree. And if you look at, if you want to figure out what controls the miles per gallon of a car, well, the big thing is going to be the cylinders. This goes to 201 now. If you just took 201, cylinders is kind of one of the big deciding variables. Like, do you have more than 5 cylinders or 5 cylinders or more? Yes. Does your car get more than 193 horsepower? Is your horsepower 193 or greater? Yes. Well, your miles per gallon is probably pretty bad with this high cylinder, high horsepower car. Does your car not have a lot of cylinders? Well, you're probably getting 27 miles per gallon. We could split this tree further. Let me go to, can I do CP cost parameter? I think you can do that right here, right? There we go. Now we get a little bit different of a tree. This is telling it only needs a little bit. Really? Really? Yeah. Wow, that's it might be due to the lack of data. We can just get the naive model now. And this is why knowing things like this right here, like these parameters are important. And this is what we teach in our classes. Like, what is the complexity parameter right here? The complexity parameter is the return we need on the either the sums of squares error reduction or the misclassification or the impurity of the leaves. So knowing what these things do is important. We don't just teach you like, here's the code. It's like, well, what does this do? What is the point of this? Well, I'm trying to make it so my tree splits further, but apparently maybe it's due to parameters. Like if you look at it's probably due, I got to do min. Is it min? Min buck? What is it? Min. Let me go look at the R part. So now we're going to go look at the function. Rows, great stuff right here. Weights, NAs, model, MuBot's talking away. Method, model, params, control. I don't see where to control the minimums. Sent a photo of a tree on the Discord, wrote up an executive summary type explanation for the permit. Oh, that is so perfect. I definitely hope, Rose, I hope, and that's what we try to tell students about our classes is like, we're just teaching you how to get good at stuff. We're teaching you how to like interpret stuff, how to read it. What does it mean? What does it tell us? Why are we doing this? What can we change? No model's going to be right. You're just going to make models and try to say like, well, this shows this says this is what we think based on this. It's all about data-driven decisions. And if you know how to make these things, you just get quicker at doing it, and you can just like slice and dice data. It's like someone who knows all the baseball stats. They're like, well, back in 1952, there was the this, and in 1980, there was this. Analytics and program skills allow us to just go through data so quickly. Like we didn't have to look at the data set. Like if I want to know why are students a certain height, I could just go to heights of students and go here to the Survey 10 data. Let's not use that sort of complexity parameter. Let's just bring it back to the norm and let it decide for me. And now we can make a model that predicts why students are a certain height. So this is a decision tree like we do in Stat 201. You can even do gender if you want. There's a decision tree on it. And I'm just changing the Y variable. It's just a different question now. So with this right here, we're able to analyze differences among genders. And you can see it really goes down to body piercings being the number one. Like, do you have 1.5, which is kind of a deciding factor between the unique values of 2 and 1? That's how it decides this value right here. And you'll notice right here, people who do have more than 1.5 body piercings, 97% of them are female, which makes up 54% of the overall data. And then if you don't have one or less, these would be these people over here. We asked then, how much do you want to weigh? These people said, yes, I want to weigh less than 137. Well, a lot of females there. And then we say, do you think you are funnier than less than 63% of the data? All males are wrong. This is a wrong model too, but it might be useful. Exactly. You can see here that males are mostly people who have 0 or 1 body piercings and want to weigh more than 137. That's like most likely male people. Like think about me, Brian, 0 piercings, and I want to weigh about 180. So I literally fall into this category right here of most male group, where females, not saying everyone is this, but most females are people who want to, no. Most females are just people with more than 1.5 body piercings. Like you have 3 body piercings, okay, you're probably female. It doesn't mean you are. It doesn't mean you are. It's just the way the data goes. And this is one set of data right here. It's just one set of data, which gives us the story. And here's the thing. We don't tell it the story to tell. We let the data speak for itself. So this is just what we see in the data and the kind of best way to classify. I've never run summary on this. What's it going to do if I get summary on my tree? Give me an R squared? Better. We're seeing the nodes, probabilities. I was just giving each node the splits. Oof, that's a lot. Maybe Tidyverse has something better. There's the complexity parameters. So yeah, there's the different trees. So the returns. So that's the return on the Gini, the misclassifications, and yeah. So this is the stats we don't do as much. But it's talking about the different leaves right here. And then the summary of it is what we want to see. But you can just pick any sort of variable, like just analyze it pretty quickly. Go to like desired weight. What best explains how much people want to weigh? I think it's that. Nope, not there. It says, no, we don't have that variable. I think it's that. It is that. And now we go, wow, this is a complex tree. This is a complex relationship. Why do people want to weigh certain weights? First off, gender equals female. Yes. Gender equals male. We only had those for this data set. And then your actual weight and so it's a lot of like, how much do you weigh, and gender variables, which would pick this. And we're just letting the data speak for itself. So some people actually weigh more, and you see a relationship here that people who weigh more kind of want to weigh more. It's pretty interesting. A lot of how much you want to weigh is decided by how much you do weigh. So more power to, yeah, pretty interesting. That's what we like to do with data. Like, how well does this do? And can we use, we should be able to, I'm interested in this, Rose. We should be able to make predictions with the tree. So here's what we can do, Rose. Let's go to predicteds. And let's make predictions with the tree. There's everybody's predicted values. Let's go to actual value. Check out what we're going to do. Rose probably knows where we're going with this. So I'm going to everybody's actual desired weight. And so we're going to survey 10 $ desired weight. And there's their actual value. And R squared, well, actual minus predicted, we can get the residual. Okay, so now we need to figure out, oh gosh, there's a lot to calculate. R squared is the formula sums of squared total minus sums of squared error divided by sums of squares total, because it's the amount of variation left, the amount of variation we explain out of the total variation. So we should have no error. So the error, the sums of squared error is going to be equal to, sorry, this is 320 towards the end of the semester. You won't be calculating it this way. Sums of squared error is equal to, so it's the sums of the squared error. Let's find the error. The error is going to be the actual minus the predicted. What does someone actually desire to weigh? What does someone predicted desire to weigh? These are the errors. So there's your error values. And then we need to do the square of them. So squared error. And so we just take the error and we square it. And then we take the sum of the squared error. So SSE, which is the sum of the squared error. And there's the sum of the squared error. So now we have a sums of squared error. We've got one component of what we need. The sums of squares total comes from the naive model. The naive model is a model where we use the mean of y to predict x. So let's go here and do the same sort of thing. But at the end, we're not going to store it as the sums of squares error. We're going to store it as the sums of squares total. So now we actually need to use the mean. So the mean will be the mean of desired weight is the predicted value. We might need to rep that. So let me see what it does. Here's the predicted. Here's the actual. Still actual, same. Oh, it worked. It worked. Looks like it worked. And now at the end of here, we call this sums of squares total because that's from the naive model. And there's the total. Oh, this model does pretty well. And so now we've just calculated R squared. There you go, Rose. There's R squared right there. Of course, we should always take R squared times it by 100. And we could say, there it is right there. And then we could go paste. We could say our model explains, and then put a percent after this. Oh, didn't end my sentence. Our model explains this percent of the variation in desired weight. And I think I've done it. End off the thing. Our model, and I don't like it showing like that. Just want to show it as this. And there we go. Our model, oh gosh. So now we need to go to a round this. I don't know. I find this one. There we go. Our model explains 86.3% of the variation in desired weight. Blank percent of the variation in Y is explained with the variation in X. You're hearing, if you took 201, if you're taking 320, you'll hear a lot of these concepts where we say blank percent of the variation in Y is explained by the variation in X. So our model explains this. So yeah. And so it does a pretty good job. There's certain things about desired weight that we don't understand, but the decision tree right here does pretty well. Now we could go to boosted trees, all these different things. But a lot of this is a 2-1 concept of R squared. And this is the 320 way to understand the mathematics of it, that it's the sums of squares. And we were doing the mathematics right here. Where did I calculate it? Wait. Yeah, there it is. Sums of squares total. Yeah, here's the equation. Sums of squares total minus sums of squared error divided by sums of squares total. And we'll walk through how this is done. We won't go this quickly. Hopefully I haven't scared people. I was trying to get my brain going again, turn the wheels in my brain for the upcoming semester. But this has been kind of the joy of coding, the fun of coding right here. Just how I like, I don't know, just to figure something out, make it work, and kind of use the skills you know. Cool. Well, anyways, we'll be back here soon. I have class coming up here in 14 minutes. Thank you, Rose, and everyone for swinging by. Classes start out really smooth. We go from the base level up, but ask those questions, whether it be on the Discord or in the chat or anything. I don't want people to be afraid. I want you to know there's always help. And by the end of this journey, which a lot of people get to, you'll be saying, wow, I know a lot. If you're like, how did Brian do all that? I have students who amaze me. Students who do stuff that I'm like, how did you do that? I hope you were. If you were impressed by Brian, Brian has students who impress him. And you might be one of those students. So think about that. Rose is impressing me right there, using the packages, finding things like Rattle that we're using that really help us out and make life easier. Our goal is to make life easier with coding. With that, we'll be back. I'll be broadcasting soon. Bye for now, everybody. Bye.